table. So I want to talk about the science, because at the end of the day, it's good science that creates good products and services, and at the heart of the TSSG is our scientific program. My own background is science to industry to science. I worked in the telecommunications and utility industries before I joined the TSG or joined WIT in 1996 and founded the TSSG. And the motivation behind it was this understanding or belief that increasingly the world was not about hardware, but it was about software, and it was about services. And the question of how do you evolve the communications infrastructure to a environment whereby the focus very much is on delivering functionality to create new and exciting services. So from 1996 on, we've been looking at this whole area of evolving communications infrastructures to be more service aware, and I'll talk a little bit about that later. So who are we? We're a world-class telecommunications communications research centre located in Waterford, but don't let that put you off. We work with people not only in Ireland but right around the world. You see some of the names there. We've strategic partners from far afield as Germany, as Tokyo, as Silicon Valley. So the main thing is that we choose our partners as those that are leaders in their fields, and we work with them to test our ideas and to deliver new and novel solutions. And in one of our principles is to use that expertise, particularly to focus in on the SME and Indigenous industry, and to help Indigenous industries to access that knowledge and the outcomes of our research. So I talked about communication and communication networks and the philosophy behind our research program. So we all know that increasingly the network itself is becoming very diverse and extending from, traditionally I would have worked here in the core network, and increasingly now we see that the communication network and the internet itself is made up of multiple networks. We have sensor networks. There's big emphasis on the Internet of Things, but sensor networks is just another communication network. We have wireless access networks, and the question really is, how do you manage the network in such a way that you can deliver end-to-end quality of experience? So we used to talk about the quality of service, but increasingly it's quality of experience. The thing about technology is disruptive, and technology is constantly changing. So if you just drive it by standards, you're in this constant battle against disruption. So what we have decided was that what you need to do really is you need to work on abstracting from the network itself to build a layer between the network and the services, so that services can leverage the functionality of the network but don't need to be network and telecom engineers. So if you look at the first phase of the internet, very much the services themselves only concern themselves with IP, the IP layer, and really in many cases ignore the network itself. But we know now with the increased evolution of the network, particularly into 5G, there's an increasingly, and in the cloud itself, there's an increasingly demand for networks to be more service aware, and for services to be able to access the functionality of the network. So very much our research is looking at both ends of the coin. One of them is, how do you actually provide application service providers with access to the functionality of the network without actually having to understand the underlying technology? And the important point is end to end. So whereas many cases there's solutions that just cover a single part of the network, we're very much focused on this end-to-end quality experience. But the second thing is, and the other side of the coin is, if we've to achieve this, and if we've to create the next generation of the internet, the future internet, and support the type of smart services that are evolving, then increasingly the network itself has to be service aware. So that's the two challenges we're working on. I'm not going to go into the detail of it, but our view is that there are two key points of the network. One of them is that you create this middle layer so that you can support multiple vertical markets, so that you don't have to have separate solutions for separate markets. The second one is that the network itself is a huge source of intelligence, and services need to be able to access that intelligence and leverage that intelligence. So those are the two things we're looking at. So if you look at some of the techniques that we're talking about here and the type of research we do, we've got looking at network architectures, particularly looking at virtualization of network resources, looking at software-defined networking. What does that mean? How do you implement it? But particularly, how do you implement it at an end-to-end perspective? So multiple suppliers will actually provide you with SDN-based interfaces, but they may lock you into a single vendor. So what we're interested in is the interconnectivity between each of these solutions. So that goes to the end-to-end quality of service and quality experience. And we look at techniques for the federation of networks and services, because first instance is the best way to overcome disruptive technology is to look at federation. How do you implement federation, and how do you manage federation? The second thing is services themselves. We now have very complex services, and services don't exist in isolation. So particularly if you look in the cloud, you've got multiple services that are co-hosted, coexist next to each other, can share information. So we're looking at that. We're looking at management techniques, both for managing the services themselves and the network. How do you scale services? How do you scale networks? What are the new protocols and techniques that allow you, for instance, when you're scaling services, to do it efficiently, to access information in the network, learn from the behavior of those services in the network, and grow. And you know, in the cloud, this is going to be increasingly important, because if you can't understand the behavior of your services, then it may be that your customer base is increasing, but the cost of hosting those services in cloud is also increasing, and your profitability is decreasing. We look at information and service personalization, but particularly, and I think this is the key point, and there's a presentation later on it, in service personalization, service providers want to provide the best services. Users want to access those services, but they also want to protect information about themselves. So there's a balance there, and there's a tension, and we want to understand how to manage those two different demands. The engineering of the services themselves, so this is really taking the science and going into the engineering case, and there's a huge area in data analytics. From our perspective, we look at data analytics in terms of leveraging the information that's in the network itself. That may be your traditional telecoms network, it may be a network of data, of sensors, and it may be a combination of both. An interesting question is, how do you actually combine information from multiple sources? The context of that information, knowing when to use that information and how to interpret that information, because quite often you collect the information at one time at one point in time, but it's something that happens further downstream that causes your need to go back and evaluate that information. So what type of additional knowledge do you have to store in order to allow yourself to be able to go back and evaluate data that's been historical data maybe, or even in real-time data? What type of data is relevant, and how do you decide which data is relevant at a particular time? So I say this is science, and it's underpinned by a number of postdocs and students, and it produces lots of papers, and it's benchmarked against the best in the world. But we're not just about science, we're about providing solutions based on our science, and we work very closely with companies to ensure that the information and output from our research can be moved very quickly into products and services. So it's very good to work with companies, even at the research end of things, to understand where the industry is and understand their technology roadmaps, and then understand where the technology bottlenecks are, so that when you're doing the science, you can actually very quickly identify areas that you can transfer that knowledge to. Here's two examples. In actual fact, both work that we did. The first one is about IBM, who is one of our strategic partners, and Martin Johnson is here somewhere. Martin, can you put up your hand? Martin actually is the I suppose the business development manager for that relationship with IBM. And this is a very good example of research we're doing funded by Science Foundation Ireland, which is really leading edge research and the application of that research into products and services in IBM. So IBM have a unified communication service, and interestingly we also worked in Cisco in a similar situation where they have a unified communication service. And their concern really was the end-to-end performance of this service and trying to understand how you optimize the service in less than ideal conditions. So you design a service, you design it in an ideal environment, you put it out there, the behavior of the network changes, the environment where people are accessing the service changes. How do you automate the service so it optimizes the quality of experience for the users? This work itself, which we did in collaboration with UCD and NUIM, it produced, I think in a period of 2 years, 19 patents underpinning this. Second one is work we did with Cisco again. It's a unified communication service that had, one of our areas of expertise is policy and policy management. So we looked at the whole area of policy frameworks in the context of network federation and governance. So how can you use policy, particularly in sense of looking at business logic and mapping that to physical layer configuration. So you have a business logic, you have service level agreements, you put your services out there on the network, it's sharing resources with other services from other companies, and you have a fault in the network itself. How do you create a situation where the network itself will automatically reconfigure itself so that it is consistent with the service level agreements that came from the business logic? So that ability to be able to map from a business model down to the physical layer and to respond based on what's happening to the network to the service itself and ensure that the service level agreement becomes consistent. Of course, it's easy to do when you have one service level agreement, but if the same network is sharing resources for 1,000 service level agreements, then you need to be able to separate these out. So the other thing is the policy itself, to do some evaluation of its performance. Is it fit for purpose? Is the policy representing the behavior of the network and the behavior of the users with that network? So all of these are challenges, and they're just two good examples of the research we've done and the mapping of that research to real products and services. Barry's going to talk next, and the message I would give you is it's important that we do the good science. It's important that we have the best postdocs and the best students, and we attract them to Waterford from all around the world. But for our philosophy and why we set up the TSSG and why I set up the TSSG in the beginning was to have economic impact. So we're constantly looking at how we take that knowledge and how we actually transform that knowledge into product and services. The first starting point to do that is in a conversation. We have to understand your business, we have to understand where you're at and what you're doing so that we can actually bring that into our own thinking and help to plan our research and help to identify areas of opportunity. So that's all I'd like to say for the moment. Thank you very much.